2012 paper Doppler's effect question 3c. Ben is on the top floor of an apartment building and has a phone that emits a single ringing tone of 440 hertz. Unfortunately, while picking up the ringing phone, Ben drops it so that it falls off the edge of the 0.7 meter high top floor ledge he is leaning on. Sometime later, Ben hears a reduced frequency of 416.2 hertz. The height of each floor is 3.10 meters. Calculate the number of floors that the phone must have fallen when it emits the wave that Ben hears as 416.2 hertz tone. So what have we been given? We've been given the frequency, the true frequency, 440 hertz, and the apparent frequency, which is 416.2 hertz. The initial velocity of the phone would be 0, and the velocity of the wave emitted is 340, which is the speed of sound in air. And then the acceleration of gravity is 9.81 meters per second to the power of -2. Step number 1, you have to calculate the speed of the source wave. So you're rearranging the equation. Apparent frequency is equal to frequency times velocity of waves divided by the wave frequency plus minus the frequency of, the wave velocity plus minus the wave's source wave velocity. You rearrange it to get this. Then you're going to substitute in the real frequency, the apparent frequency, and the speed of the wave. Okay, so you will then get the answer, 19.44 meters per second for your velocity of the source. Since the wave is moving away from the observer, you have to add this part. Therefore, when you're rearranging the equation, you'll have minus the velocity of the wave. Okay? And then step number 2, you're finding the distance using the formula Vf squared is equal to V initial velocity squared plus 2AD. You're assuming that Vs is equal to Vf. Therefore, your formula would be 19.44 squared plus 0 squared plus 2 bracket 9.81 bracket times d. Then you work out the equation to get 19.26 meters is the approximate distance that the phone will fall. And then to calculate the number of floors, we're going to let A represent the number of floors the phone is falling. So it initially falls off a ledge which is 0.7 meters. So you're going to take the number you get here and minus 0.7, and then you're dividing it by how tall each floor is. Each floor is 3.1 meters tall. So then you'll get 18.56 divided by 3.1. That will give the number of floors it drops. It falls approximately 6 floors when you round it off. And to work this out, you're assuming there is no air resistance on the phone. And yeah.